All right, I'm going to be talking about distance versus time currently. So that's what your note should say at the top, distance versus time. Okay, so the first one that we're going to talk about is at rest. What it means to be at rest. So if I was to draw my graph, so I'm going to go ahead and draw it right now. That's my graph. Okay, I'm going to draw my graph. Basically, what does at rest look like? At rest looks like this on a distance time graph. It's a flat line, okay? So anywhere the line, you can't see that, is flat. I'm going to make this not so fat. So as you see, I've changed it, but anywhere the line is flat or horizontal, that means it's at rest, okay? So it doesn't matter if it's here or here or here. It really doesn't matter, just as long as it's flat, okay? The next one is constant speed, okay? So anytime you're moving at a constant speed. So again, drawing my graph. Here's an example. Actually, I'm going to draw two different graphs, okay? So if you're moving at a constant speed, then the lines will be straight. Doesn't matter, not flat, but straight. It's a straight line, okay? It can be going up or down, all right? So all straight lines equal constant speed. Now, one thing about it is this speed right here is telling you how fast it's going. So the straighter the line is, if it's going up steeply like this one is, then that's showing you that it's pretty fast. But if it's going more like that, then that's showing that it's going even slower. You might be actually walking right here with this one. You know, the lower the steep, if it's not that steep, then that shows it's going really, really slow. Okay? And then over here in this situation, this one is, you know, maybe you're starting from a certain point and you're walking home or you're running home because this one's very steep. But if it was more like that, you know, really, really, you know, not steep, then that shows it's really slow. Okay, getting sloppy, let me clean that up. Cleaning it up. Okay, next. Next one is acceleration. Okay, that's an I over there, or known as speeding up. I'm going to just go ahead and put that. Okay, so here is what it looks like on my graph. Okay, you can speed up, and that's like you started off slow, and then, you sped up. You see how this looks right here? Right in this situation, it's really low, which shows that it's slow, but then right here, it's starting to increase in speed, and then you speed up. So you should have a curve, okay? And this is what it looks like going the other way. You can speed up going two different directions. Speeding up can look like this, starting off really slow, and then you increase in speed going back home, all right? So what this says over here is they start off straight, that's a T, and then they curve. So they're starting off, as you see right here, straight, and then it curves, okay? And it doesn't have to be that straight. It could look like that, you know? It could look like that. Just take its sweet time, all right? And the curve doesn't have to be that steep. It can look like that, you know? So as long as it's curved, all right? So, next one. Next one is deceleration. Okay, I think there's two C's in there. I don't know. Anyhow, I'm just going to leave it out. Okay, so slowing down in parentheses. All right, so what does that look like on a graph? On a graph, it looks like these ones up here, except, you know, it's going the other way. It starts off more straight, more like increase, like you're running, and then it goes flat. Because remember, a flat line means at rest. Also dead, you know. But anyhow, here's another way that it could look. It could look like this. Really steep, and then it starts to curve and then flat. So this one, in this situation, you slow down to a stop right here. Okay? So what this says over here is the line starts out steep. Line starts steep, then they flatten out. So as you see right here, it started out really steep, and then it started to flatten out. Okay, so now let's see what this looks like in practice. You want to make sure you fill out your notes too, page 18. So let's say I had this, and then I had, let's see here, then I had this. What's going on here? Which one of these is happening? This is, hopefully you said it, a constant speed. Okay? It's constant because it matches this one. Maybe this person could be running, because it's not very steep. I mean, it's not very flat. So I think maybe they're running. All right? Or like let's say I drew the line and it looked more like this. Okay, so now what would you say this person's doing? Maybe they're walking, okay? Not going very fast, okay? Because the flatter it is, the closer it is to this line, the flatter it is. Now, I broke the biggest rule of all. As a teacher, I should be ashamed of myself. I did not label my graph, all right? And as I label my graph, what should be going on the y-axis? It should be your distance, okay? And then this should be your time. So this here, let's say my time was going 1, 2, 3, 4, 5, 6, 7, all right? You cannot go this way on a distance time graph. That is a big no-no. And that would mean you're going back in time, okay? And you can't go back in time. So your arrows should always be facing the other direction, all right? They should always be facing this direction. This is good. Yes, okay?